Okay, related rates and logarithmic differentiation. Okay, so although I did do some questions in related rates yesterday, because I found it testing, I will repeat my work. That is a piece of advice that I've learned from this YouTuber called the Math Sorcerer, who seems to know a lot about maths. Okay, so in the following, assume that x and y are both functions of t, given x equals -2, y equals 1, and x prime equals -4. Determine y prime for the following equation. So first we will differentiate with respect to x. No, rather, we will differentiate with respect to t. Okay, so that would be 12y, y prime, implicitly differentiating, plus 2x, x prime, equals 2 minus, and then we have a product to contend with. So that'll be 3x squared e to the 4 minus 4y x prime plus. Now in differentiating the second function, we notice that it's a chain, and it'll result in -4. So -4 x cubed e to the 4 minus 4y y prime. Just there, like that. Now, instead of getting all my y prime stuff onto one side, I'll just make the substitutions directly and straight up. So 12y is just simply, so that first term there will just turn into that. This next term, 2 times -2 times -4, 2 times -2, so it's going to be 16. Square root of -2 is 4, so we're going to have 12. And then what's this here? Okay, so that's just 12. And -4. So -48. That turns into a 32y prime, 32y prime, so this will become a minus 32y prime. So that's 50. Take away that. That's what I think. And now to find out if it's right or wrong. Oh, gosh. Always with the arrows. Nope, I'm going to stick with it. I'm really... Oh, goodness me. The 2 disappears. Of course it does. Gosh. Really, really silly error that was. Very silly error indeed. Okay, that's fine there. Probably going to be wrong. Right, I'm going to start the entire thing again. Don't care how long this takes me, I'm going to get this right. Okay. Differentiating this, we get y prime. Differentiating this, we get 2x prime. That disappears. Then we have this horrible minus sign here. Now we just have a product, and I'm going to block that with my finger so it doesn't distract me. So 3x squared x prime e to the 4 minus 4y plus symbol. X cubed stays exactly where it is. I differentiate e to the 4 minus 4y. What happens? I get this. Now, I'm going to get rid of that minus sign. Now we just make substitutions. 12 times 1 and y prime I don't know. 2 times negative 2 times negative 4. Square negative 2, we get 4. That becomes minus 4. Oh, and there should be a y prime there. See? Just every time, every single time I drop something. It's very, very frustrating, but must continue. I cannot stand the heat in here. So 1248. 4 times -8 is negative. There. Is that better? Oh, thank goodness. All right. I'm just going to do that, even though the sound carries. It's just the heat makes it impossible for me to concentrate. Okay. In the following, assume that x, y, and z are all functions of t. Given this, determine z prime for the following here. So I will expand it out. Minus xy plus differentiate now. Okay, so we get x prime, then a minus sign, and then we open up a pair of brackets. And then what happens? Well, we get x prime y. I know this is going to be wrong. I know it will be. Look. Oh, man, I'm so sick of making arithmetic errors. Starting to annoy me. It really is. There's just no other word for it. Whatever, just continue and brace yourself for being shown to be wrong. Eight 4 take 39. So I think it's that, but here we go. Oh, phew. Got it right. Okay. For a certain rectangle, the length of one side is always 3 times the length of the other side. I'm not having this particular state ruin my entire evening, so I don't care right now. It's just bizarre, like I'm simultaneously freezing but also sweating and hot. How does that work? It's just bizarre. But I'm not having it ruin my entire evening. I really, really, really want to do some work tonight. So no one's here anyway, so it's entirely irrelevant. Anyway. Okay. Okay. Thin sheet of ice is in the form of a circle. If the ice is melting in a way that the area of the sheet is decreasing at that rate, what rate is the radius decreasing when the area of the sheet is 12 meters squared? Right. State what we know. We know that area is equal to pi r squared. dA by dt is 2 pi r times dr by dt. person is standing 350 feet away from a model rocket. It's fired straight up in the air at that rate. And at what rate is the distance between the person and the rocket increasing at 20 seconds after liftoff, 1 minute after liftoff? Okay, just plug in the numbers in and nothing else. We get something that's really, really rather remarkably small. That'll be because of the negative half. I'm still getting very, very small numbers. And these are in feet, by the way. So that's an error. Unless I've entered in them on my calculator wrong. Could be. Yeah. I made this error yesterday, didn't I? Just not correct, sorry. And I didn't understand why it was an error yesterday either. Still don't fully understand this. What actually is the error? Okay, so that's true. They agree about that. But why can you not just dz by dt? It's really important that I actually understand this time, because I didn't understand it yesterday and I don't understand it today. So I need to use whatever means I can. And that means using an LLM, which is shameful, but I have to do it because I just fundamentally don't understand what's actually wrong with this. And that's dangerous. Let Z represent the distance between the person and the rocket. Then Z equals 350 squared plus 225 times t squared, all to the 0.5. And dz by dt equals all of that up there. Then to the power of negative 0.5. And all of it is multiplied by 2 times t, is it not? So that equals this. Wait. Yeah, okay. It's still the rate, isn't it? dz by dt. The real answer is closer to this. That is my fundamental error. I'll also consult Gupta. Yeah. I mean, they get the right answer as well. Oh my goodness. I see it now. Oh my goodness me. How could I have a blind spot like that? I missed the number. That's so bizarre. It's honestly like those experiments where they show people a large change from one image to the next and people aren't able to see it, like a turbine is missing or something like that. Anyway, in doing this, let's see if this is right. Yep, that was the error. All right, okay. I'm happy about that. I'm happy to have discovered the error. Okay. 9.76187. Okay. There was also this one. This caused me quandaries. A plane is flying like this, and is actually. I also got this one wrong the other day. Let's see if it catches me out again. So that's what I think. Now we're going to see what it is. Yeah? Or is it the exact same error as yesterday? Okay. That's what I get from that. And then if I plug in 30, presumably I'll get the same error as yesterday then, right? That gives me 55.47. Right, and I remember these were like wrong, right? No, they. Ooh. Okay, yeah. That one's right. That one there is wrong. Okay, so I have a slight suspicion that they're actually wrong. You know what? What if it's just literally just simply the simplest thing possible? What if this arrow is just the wrong way round? Right? So I'm going to ask that. Towards the radar station. All right. What if I ask this now? So super standard calculus problem. There's no way it's going to mess up with this. Well, they can't both mess up. So here's what I'm doing. I'm asking the LLMs, but I ask 2 of them. And they have to give me the same answer. Okay. All right, that's concerning. So they got the same answer. Okay, DeepSeek's taking quite a while, so we're going to ask Gemini. All right, okay. So I need to know, what is my error here? So first I'm going to see if I can figure it out myself from their workings. No, okay, so they've computed it in the same way as the notes have. And this is where I need to figure out what is my fundamental error. Because if I don't get this, this is going to come up over and over again. Oh my goodness me. Oh my goodness me. 30 seconds after it passes over the radar station. Can you believe it? Can you actually believe it? I can't believe it. I understand now completely. Oh boy. Wow. Wow. Okay. So 30 seconds. And now we get the right answer. Wow. That is such a relief. I thought I was making such a bigger error than that. It was really just the question, just understanding the question. Okay, not bad. Right. Stretch my legs. Oh yeah. The heat is still raging on. Can't do anything about that though. Can't do anything about that. Well, actually, there is something I could do. There. Okay. Now back to it. Two people are at an elevator. At the same time, one person starts to walk away from the elevator at a rate of 2 feet per second. And the other person starts going up in the elevator at a rate of 7 feet per second. What rate is the distance between the two people changing 15 seconds later? Okay. So I mean, I struggle to understand why that's not 40 squared. Wait. Motorbikes. Creating noise to serve absolutely no purpose at all. But yeah, I mean, they can do that if they want. I think it's this, which is, that's 53. I cannot see how it's not root 53 times t. At the same time, one person starts to walk away from the elevator, another person starts going up in the elevator. So, and so, I can't see how it's not exactly the same. Well, I'm about to be proven wrong again because he's full of tricks. You're full of tricks, wizard. Remember that? Here we go. Let's find out. I get this same answer. This is so engineered, isn't it? Is it not? Am I underthinking it or is he overthinking it? Why? I just don't feel like it's necessary to do any of that. Oh well. We got the same answer, man. Two people on bikes are at the same place. One of the bikers starts riding directly north at a rate of 8 meters per second. 5 seconds after the first biker started riding north, the second starts to ride directly east at a rate of 5 meters per second. At what rate is the distance between the two riders increasing 20 seconds after the second person started riding? So, let that be that. Then, once again, using my technique, which is technically wrong somehow. I mean, it's not technically wrong, but it is. I mean, okay, let's think. For the north biker, we'll say 8t squared. For the east biker, the biker heading east, okay, all right, so we are actually going to have to be careful here. Okay, so the north biker he always has, or they always have a 40 meter head start. So we're going to say 40 plus 8 t, and we're going to square that. Yeah, and for the east biker, time after second biker starts. For the east biker, we'll do that. Still don't see how this is wrong, but we shall see. Okay, so I think that it's wait a minute. Did I just do all of this fancy pants work for nothing? This is so dumb. It'll be exactly the same no matter what the whatever. We'll check it, right? Okay, we get the same answer. Yeah, we get the same answer. Right. A light is mounted on a wall 5 meters above the ground. A 2 meter tall person is initially 10 meters from the wall and is moving towards the wall at a rate of 0.5 meters per second. At 4 seconds of moving, is the tip of the shadow moving towards or away from the person and towards or away from the wall? What an interesting question. If you don't mind, I'll be borrowing that. Thank you very much. Oh, wow. Okay. Really not too sure what they're actually sort of asking here. I mean, the person's gonna be closer. So what are you asking me to analyze that situation? By similar triangles, that's 2/5, is it not? And so that there. So that's 40% of the height. So that'll be 40% of the length. And if 60% of the length is 10, then what you do is 10 divided by 6 and then times that by 10. You get 100 divided by 6. %40 of the height, 40% of the length. And so 60% is 10. And if 60% of something is 10, that means 10% is 10 over 6. So 100% is 100 over 6, which is 16 2/3. That's 10 there. And that's 6 2/3. That's what I think anyway. And then after 4 seconds of moving, that's obviously still 5 meters tall. And then it's going to be 2 meters less. So that'll be like 8. And that'll still be 2. Mm-hmm. So like 40/3. And therefore, well, 40/3 is 13 1/3. And what's the actual question? After 4 seconds of moving, is the tip of the shadow moving towards or away from the person, and towards or away from the wall? So I do not understand how it's not just obviously towards in both cases, but I guess I'm going to be proven wrong. I guess yeah. See, I mean, I thought like intuitively and physically, like surely this is just obvious, and then I had to check it was like elementary geometry, but apparently this is a calculus question. Don't get it. That's fine. 10. A tank of water in the shape of a cone is being filled with water at a rate of 12 meters cubed per second. The base radius of the tank is 26 meters and the height of the tank is 8 meters. At what rate is the depth of the water in the tank changing when the radius of the top of the water is 10 meters? Note the image below is not completed scale. Okay. So it appears. Oh no. No. Wait. Oh, the depth of the water. Oh, goodness me. Okay. That's fine. I just went for the wrong quantity. We want the rate of change of h, don't we? Wait, so why don't we just do dv by dh? Do you know what I mean? differentiating that with respect to h. But we notice that that is r right there. So set up a relationship between the radius and the height for this particular cone. So you divide that by 26 and times it by 10. Forty over 13. Am I even thinking about this right? All this just to get dr by dh. Oh. rubbish. My calculator is probably not even going to be right. Probably not even going to be right. But still. I mean, what? It's just such a mess. Half minus half. Then how do you differentiate that? Okay, so this is just completely garbage. It's so wrong-headed. It's unbelievable. And look, it's even worse because this is in terms of h, and that's in terms of r. So how am I supposed to? Where am I supposed? What, I'm going to plug in 10 into there, and then what am I going to do about h? It's rubbish. It's just rubbish. What would I do then instead? What, get dh by dr and then do the reciprocal of that? Just silly. Just silly. I mean, it's true what I've said there, though. That's true. We know that. Okay. Right. Just eliminate one of them. Okay. All right. You know what? It's quite enough for this for today. Well, it's enough of related rates for sure. Now we're going to move on to logarithmic differentiation. Yeah, overwrite that. Get the new one. Oh, wait. Here. And now, let's get on with it. Okay, differentiating the natural logarithm, we get 1 over x. And then when we differentiate the natural logarithm of f of x, we get, by the chain rule, f prime of x over f of x. So okay, here's the deal. After I complete this, I get to do like stuff that I find more fun, because little tiny bit tedious at this point. So f prime of x is the original function multiplied by this. Okay, that'll be 6x plus 4 on the top. But then we can cross out yeah, so it'll be like that. So I believe. But we're about to see. Or I guess not, because it's in slow loadio mode. Slow loadio mode. Be careful. Hear a strange sound. Oh no, beg your pardon. That's not true. That's actually ln of y, isn't it? And therefore, dy by dz over dy by dz over y. Whoa, hold on. Oh, I think I can do that trick. Okay, so here we go. Okay, that's wrong. Because it's the derivative over the actual function itself, as you know. And then it's the derivative, which in this case is minus 4z cubed. Just like that. All of that. Yeah, I cancelled out a factor of 2. Interesting. They called it cot. They saw that, and I didn't. Kind of jealous. But you live and you learn. All right. Okay, this one we really need logarithmic differentiation for. No blimmin' way. Ln of h of t half of ln half of log of 5t plus 8 plus a third of ln 1 minus 9 equals 4t minus a quarter ln of t squared at 10t. And consequently, upon differentiation, 2t plus 10. So t plus 5. Well, to answer the original question then. That. I'm not sure where I did that. That's weird. It's also kind of strange move, but yeah, whatever. All right, so he did it. So it was all fine. Okay. Derivative of a product. Derivative of a product. Oh, I'm sure they gave me the actual rule for doing this. Man. All right. We'll proceed anyways if we don't know it. That would just be 4 plus. Leave the first one alone. Multiply by the derivative of the second one. There. Okay, good. Then all of that multiplied by that. Oh, darn it. Oops. Big oops. Forgot to bring out the factor. 2. Yep. But otherwise, it's okay. Oh, I'm really happy. Really happy. I get to move on to chapter 4 now. But that's for another night. Be well, be well.